In this video, I'll show how to create the basic geometry of our heatsink product and then run a thermal solution on it to see how some changes to the design can increase its heat flow. Let's begin by creating the cube part of our design. The size of our aluminum cube that we have to start with is 1 inch, so I'll type that in. Hit tab to move to the other dimension. That's also 1 inch. If you add the units behind the numbers that you enter, you don't have to worry about changing the default units in the program. From millimeters to inches, it'll do the conversion for you. I'm then going to pull this shape upwards by 1 inch. So I'm going to click the area I want to pull, select the arrow and drag it, and it will keep this text box selected for me. I'm going to enter 1 inch again. So now we've got a cube in all dimensions that is 1 inch. Navigating wise, if you hold down the center mouse wheel and move the mouse, that is the orbit. If you hold down shift in the center mouse button, that's the pan, and if you hold down control in the center mouse, that's the zoom. So if you keep your left hand on the keyboard, that can be handy. Next, let's add the circle that will be the rod attached to this. It knows intuitively that this is the plane I want to work on, and it marks the center, which is nice. If it hadn't, you can always change your sketch plane with that option to put the plane on any face that you want. I'll keep it on top. I'm going to click in the center and drag outwards, and the radius of the diameter of our material is a 1/2 inch, so 0.5 inches. Hit enter on that. And the maximum length that our rod can be is 6 inches. So I'll type in 6 inches there and hit enter. Zooms out so that we can see the entire object now. I'm going to orientate it so it's a little bit more like the position that I expect it to be in when it's in our hot drink, with the cube up and the rod down. With this basic design, let's run a thermal solution on it. So I'll create a solution. Thermal is the one on the far left. If you're ever unsure, you can always hover over them to see the names of the types of solutions. And I'm going to set it to the default aluminum, even though the properties of this material in the material library might be different than the aluminum that we're actually using. We can always adjust that later. So go ahead and create. Nothing changes because, like all the solutions, you need some minimal boundary conditions to be defined. In this, we have to define at least one heat source. Before I get that, I'm going to click on one of the faces up here and add a probe. So if I drop down the menu here, we can get a lot of data out of this. Let's look at the heat transfer on that face, because that's the thing we want to do, is see how much heat is transferred out of the drink to the environment. So now I've got this graph that I can track. It'll show me the watts of energy leaving that face, so that's joules per second, and the design points correspond to changes in the geometry that I've made. We haven't done anything yet, so there's no data, and there's no heat transfer because I haven't defined a heat source. The rod will be in our water, which will start off at boiling, so I'm going to click on that face and add a new input source here. And you can define this in a lot of ways. I'm going to define it as a new temperature. If it's in the 100 degree Celsius, that's boiling water, so let's make this 100 and hit enter. Now that it's got enough information, it actually runs the simulation and gives us some meaningful data back out, so color coded there. The design, let's change our geometry now and see how that affects our heat transfer. So maybe if I put a hole in the middle of this face, that will change the surface area and give us some interesting design point. Let's select this as our sketch plane. It's sometimes hard to see where the grid is when it's running the simulation, so we can turn that off with a button down here, and now we can see the grid on that face. Let's say we drilled a 1/2 inch hole out of that face, 0.5 inches, enter. I think that was something wrong. I'm going to Control Z to undo that. Let's try that one more time with a 0.5 inches. I think I forgot the decimal. There we go. And then I'll use the pull tool to pull that circle all the way back. And you don't need to be precise. As long as you go all the way to the opposite face, it will intuitively make that a hole. And I can look through there, and indeed that goes all the way through. Turning the results back on, we can see that has changed the distribution of the temperature on the surface. and we see that that actually decreased the effectiveness of the heat transfer up top. So that might not be a design change I want to keep. I'm going to Control Z to undo that and go back to this point. Let's try putting a ridge or a valley in the middle of our object here that goes down. That's something that we could relatively easily mill on the metal mill. So I'm going to change my sketch plane. Get that button there. So down here I can change my sketch plane to be the top, and if I want to see the grid there, I'll have to turn off the solution. In the sketch menus, I'll select the rectangle, and I could be more precise about this, but I'm just going to make any sized shape across there right now. Now that I've created that two-dimensional shape on the surface here, I can select it separate from the others, and with that selected, I'll grab the arrow and pull this down just an arbitrary amount for right now. The results over here, I can see that greatly increased the heat transfer there. So my 6th and 7th change that I made, that looks like a good one to keep right there. If I turn on the results here, I can see that there's a big temperature differential between the top of my heatsink and the bottom part that's in the hot water. So that's probably going to be something that I want to keep, maxing out at about 2.5 watts or joules per second of energy transfer there. So I'd say that's something to keep. Just to show one more thing, let's add another fin, maybe cut this one in half by putting an extra valley in there. So one more time, I'll select my sketch tool. It by default has selected that bottom of the last trough as my sketch plane, which is not where I want to begin. So let's define a new sketch plane up on top here. Let's make it so that we can see our grid and add that rectangle now somewhere there. Going back to pull and selecting that new shape. If I pull that down, this would be like routing out that shape using the mill. We can see now that has further increased the heat transfer on the faces of our design, so that's a good thing. Looking extra cool over there, so that's great. This does look like it is relatively warmer, but that might have something to do with the way that it auto-adjusted the scale here. And we could keep a temperature probe on there to see that for sure. Remember, there's other ways you can look at your design here. So if we want to look at heat flux, flux is the amount of something that passes through a defined area, and heat would be the object that we're most interested in, so the energy flowing through there. We can see the places that have the most energy transfer, and expecting that would be here. This is all at a uniform temperature of 100 already, so there's no change in temperature there, but as soon as it reaches this new object, that's where it maxes out. Here further up in the design, I can see I've got this kind of middle color on the scale. That means there's a lot of heat flow going up this fin. So maybe I want to maximize designs that look like this versus some of the other things that we tried. Okay, hopefully that gets you started on a way to create your geometry and make some changes and use the data that it provides to further inform your design.